Okay, so in 1-6 we talked about polygons. What were polygons, how to classify them by the number of sides, how to figure out if they're convex or concave, and then what regular, equilateral, and equiangular mean. So what does equilateral mean? All the sides are equal. How about equiangular? All the angles are equal. And regular? All the sides and all the angles, okay? So number 1 just says draw a convex hexagon. Hexagon has how many sides? 6, so yours doesn't have to look exactly like mine, okay? Probably a little bit neater. But I need 6 sides, and I need it to be convex, which means no side can be extended to where the line would go inside, okay? Something like that. Doesn't have to be exactly like that. Number 2 says this figure shows the tiles on a kitchen floor. What type of polygon of tiles are they? Regular polygons. So what do we think those shapes are? Quadrilaterals. Do they appear as though their sides are congruent? No. Do they appear as though their angles are congruent? No. So these are not regular. And then number 3 says the figure's a regular polygon. Find the length of each side. So if it's regular, what's it telling you about those side lengths? They're equal. So x squared plus 6x equals x squared minus 10x plus 32. And then I need to come on my like terms. I'm going to get the x squared. You don't have to go in this order, but the x squared is the same side. And these cancel. These cancel. I end up with 6x equals negative 10x plus 32. Add the 10x. 16x, God bless you, equals 32. Divide by 16. And x is 2. The question says find the length of each side, right? So I'm going to take that 2 and do what with it? Does it matter which one? So this has like one less term. Maybe plug it in there, but honestly it doesn't matter. The best thing to do would be what? Do both and check. So that one's 16. And then this one, 2 squared minus 10 times 2 plus 32. 4 minus 20. Negative 16 plus 32, which is 16. So confirmed that my work is correct. And this time they gave me a unit, so I would say that this is 16. Each side length is 16 centimeters. Questions on the warm-up at all? So big takeaway from this section is vocab as far as like the names of all the sides, what regular means, what equilateral means. This is stuff that will literally carry us through for months, all that vocabulary stuff. So it's definitely stuff that you want to make sure that you understand. Okay. So 2:1, we get into chapter 2. And it's a lot of if-then statements, a lot of logic-based statements. 2:1 is kind of just the introduction to it. So it's called using inductive reasoning, okay, which is establishing a pattern or finding a pattern. It's funny that this section is kind of a hard thing to teach you to identify a pattern. It's some of those things that most of you have that natural ability to kind of like see it, and some of you it might not come as easily to. You just got to work with it. But there's not a set pattern. You're not always going to see a certain thing. So you've got to be able to adapt to the different kinds. So a conjecture. All right, so a conjecture is an unproven statement that's based on observation. So you assume a pattern is occurring, and that would be a conjecture, okay? You, based on information, can assume that this is happening. That would be a conjecture. Inductive reasoning is a process that includes looking for patterns and making conjectures. So you're looking at something, you're saying, I think this pattern is true, and if this pattern is true, then the next couple of numbers would be this, or the next couple of steps would be this. So that's really all the vocab in this section. That's really all you need to know. The next couple of things are how do you apply it, okay? So the practice is what's going to help with these patterns. So this one says, describe how to sketch the fourth figure in the pattern and then sketch it. So in figure 1, what do we notice? It's split in half and one component is colored in, right? How about in figure 2? Cut into fourths. How many are colored? Still 1. Figure 3. cut into 6. And how many are colored? 1. So what do we think is going to happen the next time? Cut into 8. How many things do you think are going to be colored? Still 1. Okay, so to your best ability, draw what it would look like. Okay, again, doesn't have to be perfect, but you want a circle that has 8 parts to it, like a pizza, and one of those little sections is colored in. So that is, describe how to sketch the 4th pattern. So we did it orally, but you would say, divide the circle into 8 parts and shade 1. So again, this is in your own words, it doesn't have to be exactly that, but describe how to sketch the 4th pattern would be that, and then sketch it, and it would look something like that circle that's there. Okay, example 2 says describe the pattern in the numbers, and then write the next 3 numbers in the pattern. So it's going from 5.01 to 5.03 to 5.05 to 5.07. So what's happening in that pattern? Going up by 0.02 or 200ths. Okay, you can use any kind of terminology like that. So it's increasing, going up. Any of those words are okay. Please see example 3 at the end of the video. Okay, example 4, numbers such that 3, 4, and 5, so this is what we were just talking about, are consecutive integers. So consecutive integers are one whole number after the other, increasing by 1. So 3, 4, 5 are consecutive integers, 5, 6, 7 are consecutive integers, okay? This is make and test a conjecture about the sum of any 3 consecutive numbers. So pick any 3 consecutive numbers and see what the sum is. And then you want to test it. So pick another set of 3 consecutive numbers and see what the sum is. Maybe do a third and then see what you can determine about the sum of 3 consecutive numbers. Now, they're not going to be the same, right? 1, 2, 3 is not going to be this. If I add those, it's not going to be the same as like 101 and 102 and 103. But there is something that you can determine from them. So go ahead and pick 3 sets of 3 consecutive numbers. Find their sum, and then see what you can determine from all of those sums. All right, so give me their 3 sets of numbers. Emily. And when you add those up, you get 36, and then you did? So what do you notice about these? Okay, so your middle number is always multiplied by 3. Anybody else come up with something else?
Every time you add one number to each of the 3 numbers, it goes up by 3.
You're increasing by 3. Okay, anything else?
They're all divisible by 3.
They're all divisible by 3. So all 3 of those are true, right? All 3 of those can be determined. So when it says make and test a conjecture, so your conjecture could be that the sum of 3 consecutive integers will always be divisible by 3, and then your test would be these 3, okay? It could be that if I add the 3 consecutive numbers in an order, that it's going to increase by 3, so it's my pattern. And then what was yours, Emily, again? The middle number is always multiplied by 3, okay? So all 3 of those could have been proven and tested. Does that make sense? Any other questions on that one? Anybody not see one of those 3? Okay. All right, so I'm going to go back to that last example because the wording even threw me. Okay, so the wording exactly says, given 5 collinear points, make a conjecture about the number of ways to connect different pairs of points. So I'm an idiot because I missed the word different. So we're not always saying connect 1, we're not always saying connect 2, we're just saying connect them in different ways. So I'm going to start with 1 point. How do I connect 1 point to 1 point? Right? There's nothing to even connect there, right? I can't connect 1 point to 1 point, right? So how many times could I connect 1 point to 1 point? 0 times. Now let's say I've got 2 points. How many ways can I connect this? 1 way. Okay, now let's say I've got 1, 2, 3 points. How many ways can I connect 3 points? This is 1, this is 2, this is 3. Everybody see that? Okay, now let's say there's 4 points. 1, 2, 3, 4. I've got 1, I've got 2, I've got 3, I've got 4, I've got 5 ways to connect those 4 points. Everybody see that? Yep. And then it said 5 points. 1, 2, 3, 4. Oh my word. I did 1 to 2, 1 to 3, 1 to 4, 2 to, oh, here we go. This way. Thank you. Okay. Now I've got 5 points. So 1 to 2, 1 to 2, 1 to 3, 1 to 4, 1 to 5. How many am I at? 1, 2, 3, 4. That's 4, right? Then I can go 2 to 3. I can go 2 to 4. I can go 2 to 5. So 1, 2, 3, 4, 5, 6, 7. What else can I connect? 3 to 4. That's 8.
3
3 to 5, that's 9. 4 to 5, that's 10. So we went up 1, we went up 2, we went up 3, we went up 4. Everybody see that? Okay. So like I said, I think determining patterns, especially when you have to like, try to figure out the wording on it, obviously it's a challenge. Most likely if this is on a quiz or a test, it would be a very blatant way to determine a pattern, not so much with the figures or something where you have to figure out what they're trying to say to begin with. Or I could have given you a diagram with 1 point, 2 points, 3 points, 4 points, and 5 points and said, figure out how many different ways there are to connect 2 points at a time, okay? So the wording on this example I think is a little rough. If I had said the words, connect 2 points in a different way, it would have been a lot clearer. Am I right? Yeah. Okay, questions overall on 2-1. So 2-1 is all about patterns, and then 2-2, which is tomorrow, we're going to start to get into if-then statements.